Hey guys, I have a really exciting video for you today. Today we're going to be doing an experimental video. We perform 2 experiments to help us gain some insights on springs and the simple harmonic motion that comes from them. Our first experiment is going to help us determine what the spring force is proportional to, and our second experiment is going to help us determine what the period of a spring, or how long it takes a spring to bob up and down, is proportional to. I want to give a big thank you to Mr. Lordan, one of the physics teachers at my high school, for giving me the springs and the masses that allowed me to perform this experiment. So, let's get right into the first experiment. Let me describe our first experiment. I'm going to start with 2 identical springs. On one spring, I'm going to put an 150 gram mass. And on the second spring, I'm going to put a 300 gram mass, which is double the weight. And for both springs, we're going to measure how much the spring displaces from its original length to its final length after we attach the masses to the spring. And if you're confused why the springs would go down after we attach the masses, it's because the masses are going to apply a downwards force onto the spring. So let's do the experiment. Hey guys, so we're here at the setup for the first experiment. As we can see, we have a spring that's hanging from some beam, and I've drawn a black line to label the starting length of the spring. And I've also put a ruler right next to the black line, and it's starting at 0 where the black line is. So, when you want to find the displacement of the spring, after I put the masses in, all we have to do is see where the masses get to on the ruler, and that'll be the displacement, because it's starting at 0 for where the natural length is. So let's get right into it and put the 150 gram mass. And it's composed of an 100 gram mass and a 50 gram mass. And it's oscillating, but we're going to save that for later. And so we can measure it better, I'm going to stick the skewer in and see what number it's close to. So, okay. As we can see, the skewer is at 3 centimeters. So the spring has 3 centimeters of displacement for 150 grams of mass. But that doesn't tell us much unless we have something to compare it to. So let's double the mass for 300 grams, and let's see the displacement that this spring gives. So, sorry, let me set it up back nice. Let me add the 300 grams, which is just 300 grams masses, and let me put the skewer into it. And as we can see, it's at 6 centimeters. So there are 6 centimeters of displacement when we doubled the mass to 300 grams. Let's go to the whiteboard and see what this means. Alright, so to recap our experiment, we found that the displacement of the first spring, which I call A, is equal to 3 centimeters, and the displacement of the second spring, which I call B, is equal to 6 centimeters. And to understand how this relates to the force of the spring, let's draw free body diagrams of the mass and the forces on it. So there's only 2 forces on the mass. The force of gravity downwards, and the force of the spring upwards. And you'll notice that I've drawn these 2 forces with the same length as each other. Well, my drawing's not that good, but they have the same length as each other because they have the same magnitude. And the reason why the force of the spring is equal to the force of gravity, well, it's the same magnitude, is because this mass had no acceleration. So, the forces on it must add up to 0. Okay. And now let's think about what happened to the force of gravity when we increased the mass from 150 grams to 300 grams. Well, when the mass doubled, the force of gravity also doubled, because instead of mg, it was 2 mg. And that means that because the force of the spring and the force of gravity have the same magnitude as one another, that means that the force of the spring also doubled. So, between case 1 and case 2, the force of the spring got twice as big. And if we're looking at our displacements, the displacements got twice as big. So, that must mean that the force of the spring is proportional, and that's how you say proportional, to x, or the displacement. And as it turns out, that the force of the spring is only proportional to x. And I'll let you in on a little secret, and the equation for the force of a spring is just negative kx. And k is some constant that depends on the spring that you're using. So some really stretchy springs will have a smaller force. And the reason why there's a negative here is because x will always be in the opposite direction of the force. Okay, so that's the first experiment where we showed that it's proportional to x. And now let's get right into the second experiment. Alright, so here's our second experiment. And our goal is to find out what the period of the spring is proportional to. And I have some guess that it might be proportional to mass in some way. So let's find out. How are we going to find out? Well, like last time, I'm going to have two identical springs. On one spring, I'm going to put 150 grams of mass, and I'm going to put a timer on the screen, and I'm going to stop the timer once it does one rotation, or one cycle. And we're going to measure that number. And for the second spring, I'm going to put 300 grams of mass, and I'm going to measure the number of that period. And then I'm going to compare our answers, or what we measured, and we're going to see what we find out. Let's get right to it. Alright, so we're at the setup for our second experiment. So let's start by putting the 150 gram mass onto the spring. And let me pull the spring down, and let's measure one period. And with some editing magic, there should be a timer that appears onto the screen. Okay, because of air resistance, the period goes down quite quickly, but it should still be measurable. And for good measure, let's see what the period is going to look like if I stretch the spring a bit more. Does it change? Does it not change? Who knows? Alright, so now I'm going to exchange the 150 gram mass for 300 gram masses. So let's do that. Alright. And I'll pull it down and another timer should appear. Quite nice oscillations. And that's all. So let's go to the whiteboard and analyze the results that we found from the timer. Alright, so I've written the results of our experiment up on the board. The period for the 150 gram mass was approximately 0.43 seconds, and the period for the 300 gram mass was approximately 0.60 seconds. And the other experiment, where the displacements doubled, it was very easy to see the correlation. But when I'm looking at these two numbers, it's not quite clear what the relation is. The only thing that's clear is that as the mass got bigger, the period got longer. Let's divide these two numbers to see how many times this 0.6 is bigger than 0.43. So when you do 0.6 divided by 0.43, you get 1.40. Now, that might also not ring a bell, but if you like math, you might notice that this number is very similar to the square root of 2, which is equal to approximately 1.41. So these numbers are very close. So, I think it's safe to say that the period of a spring with a certain mass on it is proportional to the square root of the mass. In other words, if the mass got 4 times as big, the period would get the square root of 4, or 2 times as big. And that's correct, and our experiment showed that. Okay, well I hope you liked the experiments and you learned a lot about springs, and thank you for watching the video.